40? 40 wasn't a part of AMI.
Oh, was it?
No. Because it was just 6 through 10 even, 15 through...
That's all it was?
Yeah, the other part's 1, 3. It is part of 1, 3, but the rest of that's or the first set was AMI, the second part was actual 1, 3 homework.
Oh, okay. Can we do 40?
Yes.
Okay. Yeah.
40 from 1.3.
Big red ball, or here's what should it be? There's supposed to be a big red ball and do that art, and it's gonna like go around.
So secant is the same as 1 over cosine. So cosine's the same as 1 over secant. So that's it. Cotangent of theta. Now there's different ways we can get to cotangent of theta. One of them is with the fact that cotangent's equal to sine over cosine. Or we can do 1 plus cotangent squared. Is equal to secant squared of theta. Well, secant's value is 5. Five squared is 25. Square root both sides, telling us that cotangent of theta is equal to the square root of 24, which is going to be, should be 2 square root of 6. Yep. So B is, this would actually not be B, this would be technically C, because cotangent of theta is 2 square root of 6. B is asking for cotangent of 90 minus theta. So, questions on A or C before we look at B. Bless you. Now, cotangent of 90 minus theta is one of our properties, or, well, one of the properties with this here is that cotangent of 90 minus theta is going to be equal to tangent of theta. That's part of 1, 2. Odd. Yeah. And tangent's 1 over cotangent, so we can say that this is 1 over 2 square root of 6, right? Which would be square root of 6 over 12. Would be B, and that just leaves us with part D. C is cotangent's 2 square root of 6. And the last one's sine. No, because I just asked for, I think, cosine, sine, cosine, cotangent, cotangent of 90th minus theta, and then sine are the ones we have.
For B, can we put, do we have to put cotangent of 90 minus theta, or can we put?
Just, well, square root of 6 over 12 is the answer we're looking for. And for sine, we can again use the trigonometric, our Pythagorean identity. That's sine squared of theta plus cosine squared of theta is equal to 1. Because we know cosine is 1 over 5. So we have 1 over 5 squared. So our 1 over 5 squared is going to be 1 over 25. I'm ahead of myself. Then we can subtract 1/25 from both sides, telling us that sine squared of theta is equal to 24/25. Square root both sides, telling us sine of theta is equal to 5 squared root of 24 would be 2 square root of 6. But we could plug in square root of 24 over square root of 25 in the calculator to get our answer. Questions on 40? So if it doesn't give us nice ways to get there, this is one way that we can do that. Another way we could have done this, make a triangle, theta, cosine adjacent over the hypotenuse. And if we use Pythagorean's theorem here, a squared plus b squared is equal to c squared. One of our sides is 1, don't know the other, and c is 5. Scroll down. Well, 1 squared is 1, plus b squared is equal to 25. We minus 1 from both sides, telling us b squared is equal to 24, square root both sides, so b is 2 square root of 6. So our tangent, see here, opposite over adjacent, would give us the 2 square root of 6. It's a little flipped, but yeah, because sine would be 2 square root of 6 over 5. That works out for that. Cotangent would be our opposite over adjacent over opposite. Make sure cosine adjacent opposite, or adjacent hypotenuse. Yes. Yes. Tangent opposite over adjacent, which would give us 2 square root of 6 over 1, not. All right, that's odd. They should, because cotangent. That doesn't agree. We did get the right answers. It's just that those two should be, yeah. Because cotangent would be adjacent over the adjacent over opposite. I'm just making sure I don't have C and B flipped, because I think I might. Because it's 1, 2, 40, yes?
1, 3.
1, 3, 40. B is indeed square root of 6 over 12. C is 2. Yep. And B is asking for cotangent of 90 minus theta, I believe. B is cotangent of theta. Oh yeah, so no, this is B. Yeah, I just had them flip. That's what happened. See, okay, that makes more sense. Because cotangent is adjacent over opposite. Yeah. Okay. That's still odd, but oh, yeah. B is cotangent theta. Is based off this triangle. Tangent would be opposite over adjacent. It would be the other way. Secant, so 1 over cosine. That's why, yeah. Yep, that is right, 1 over 5. Because it's hypotenuse, adjacent over hypotenuse, hypotenuse over adjacent. Yep. Nope. Yeah. Cotangent. Adjacent. Okay. That's just, yes. Tangent. Tangent of this. Because it's really saying cotangent of 90 minus theta is really just looking at cotangent of this angle over here. Yeah. But again, the formulas will give us this here. I don't know why they're getting that. Why is the triangle not right? My nose is not helping it. Secant of theta. Secant's 1 over cosine is what we have, and yes. So if secant's that there, cotangent of 90 minus theta is equal to tangent, yes. Tangent, if we have this set up here, of this angle is going to be opposite over the adjacent, which should be square root of 2 over 1. Yeah. Should be the flip of that. So cotangent of 90 minus theta should be square root of 2 squares of 6. And cotangent of theta minus, what is, no, it's not so much the questions hard, it's just, I think I'm reading, huh? Cotangent of 90 minus theta. Let's see, yep. Nope. That's why. Okay. Okay. Yep. All right, guys. So I do need to change that because I had those flipped. Because cotangent of 90 minus theta is equal to tangent. Tangent is the opposite side over the, so it'd be 2 square root of 6 over, which is, cotangent is adjacent over the opposite. Which would give us our square root of 6 over, which would give us our square root of 6 over 12. I had those flipped. That's why that wasn't working out. Because there's two ways we can get at it. One is just from the formula. And I think that's what it was. I think I know. Yep. Okay. All right, guys, table that for now. Now, the one part that got, because the formula 1 plus tangent squared is equal to secant squared, that's where I got this flipped and why we got the opposite values. Cosecant and cotangent go together. So we could actually use this here, and that's what I ended up doing, was found tangent, not cotangent, of our 5 squared. So when we solved this earlier, that's why it gave us the wrong value. I think that's why you were asking about finding cosecant. Yep. Because tangent of theta would be our 2 square root of 6. That's where we get that from. Yep. So if we found sine, then we could find the others. We can look at another one of these if you all want. Guys, because it's 41. Cotangent of alpha is equal to 3. Because, guys, is...
Oh, is 41 on there?
I do not know.
I think it's 43, but I don't know.
I'm just picking the next one.
I was confused.
These will work every single time. We're just using the formulas to find the other parts. Now I'm just going to find all of them because cotangent of theta alpha equals 3. Tangent of alpha is 1 over 3 because cotangent is equal to 1 over tangent, or the flip. Now if we want to find sine or secant or cosecant, we can go straight from here. So since cotangent's 3, 1 plus cotangent squared is equal to cosecant squared. 1 plus 3 squared is equal to CSC. Now our 3 squared would be, so our CSC squared of alpha is just going to be the square root of 10. And we can do those simplifications with the radicals in the 30xs. So we have CSC of alpha is the square root of 10. Sine of alpha is 1 over the square root of 10. Simplify the radical. It means sine is equal to the square root of 10 over 10. Now there's two different ways we can get the cosine. We can either find secant or just find cosine. As sine squared of alpha plus cosine squared of alpha is 1. Well, sine squared we already found, or sine we found, square root of 10 over 10 squared plus cosine squared is equal to 1. Square root of 10 over 10 squared is going to be 10 over 100. Now we're going to get cosine by itself. There's going to be 90 over 100. And if we square root both sides and simplify, cosine of alpha is going to give us, well, not 3 over 10, because we can plug this in a calculator, let it do it for us. The square root of 90 over square root of 100 is 3 square root of 10 over 10. And lastly, secant is 1 over cosine, so 10 over 3 square root of 10. Again, we can let this 10 over 3, second square root of 10, square root of 10 over 3. And we can get these here. And again, that's just using our formulas. Triangle cotangent is adjacent over the opposite side. Since it's not given, it's understood to be 1. Pythagorean's theorem states that a squared plus b squared is equal to c squared. 3 squared is 9, 1 squared is 1. So c is equal to 1.3. So tangent would be opposite over adjacent, 1 over 3. Cosecant, CSC, because it's our cosine, our sine, opposite of sine. Well, sine is opposite over the hypotenuse. It's 1 over square root of 10. It's got square root of 10 over 10. Cosecant is hypotenuse over the opposite side, so square root of 10 over 1, or square root of 10. Cosine, adjacent over the hypotenuse. 3 over the square root of 10, which are to simplify 2, 3 square roots of 10 over 10. And secant, hypotenuse over adjacent. And we get these here. Other questions on the homework? No? Okay. Yeah. All right, we're picking up where we left off yesterday. So we need to find sine, cosine, tangent given the point -9, -12. So our sine of theta is y over r. Cosine of theta is going to be x over r. And tangent of theta is y over x. Now tangent we can get just from the point, because our y value is -12. Our x value is negative 9. So telling us tangent of theta is equal to negative 12 over negative 9. And that can reduce. The negative and negative would give us a positive. 12 over 9 would be 4 over 30. Now, if we want to do this with the triangle and use these here, our two distances, the distance for x over would be 9, negative 9, the distance down would be negative 12. Now, the only thing we need to find is the hypotenuse, or our r value. Well, r is the square root of x squared plus y squared. X squared would be negative 9 squared. Our y squared would be negative 12 squared. Now at this point here, we can let the calculator do all the work. Second squared, negative 9 squared plus negative 12 squared. We would need the parentheses around the negative 9 and negative 12. But it just tells us that the hypotenuse, or our r value, is 15. Which means for us, sine y over r opposite over the hypotenuse would be negative 12 over 15, which would reduce to negative 4/5. Cosine would be x over r, or adjacent over the hypotenuse. And that's all in reference to this angle here. And negative 9 over 15 would be negative 3/5. And that's our sine, cosine, tangent. If we wanted to know our cosecant of this here, we would just flip sine. Because it's 1 over sine, so 1 over negative 4/5 would become negative 5/5. Secant, 1 over cosine, 1 over
5/4.
Yep. Cosecant CSC would be 1 over sine. SEC secant would be 1 over cosine, so we flip 3/5. We get 5/3. And cotangent would be 1 over tangent, or we just flip tangent's value, which would give us 3/4. Questions on this here? Questions on anything we've done so far? Next thing we're talking about is reference angle. A reference angle is an angle whose value is between 0 and 90, 0 and 90 degrees. So the reference angle is always going to be between the x-axis and wherever the angle is. Now they don't list the first quadrant because whatever angle we have in the first quadrant is going to be the reference angle. So in the second quadrant, we're going to take whatever angle is given to us and subtract it from 180 or pi. So if it's between 180 and 90, we take that angle and subtract it from 180 or our pi. In quadrant 3, we're taking whatever the angle is, our bigger angle, and subtracting pi or 180 from it. We're taking this amount here away so that we're left with this little bit. In quadrant 4, we're taking whatever the angle is and subtracting 2 pi or 360 from that angle to get this little bit here. Because those reference angles and the angle itself will give us the same value. So what we want to do next is find some of these reference angles. Now for A, 300 degrees. For here on a quadrant, in our quadrants, 300 degrees is going to be down here. Because this here would be our 300 degree angle. So our reference angle is going to be this angle here. We'll call it alpha. So to find this angle alpha, we take 360 because it's in quadrant 4 and subtract it from the given angle. So 360 minus 300 would be 60. So this angle here is 60 degrees. Our reference angle for this would be 60. Questions on this here? Are you ready for the second one? Second one, our angle is 2.3. It does not give us a degree marker, so it's understood to be radians. It's a radian measure. Now our radian measures 0, pi over 2, pi, 3 pi over 2. We need to figure out which quadrant it's in. Well, pi is approximately what? Or the decimal value for pi would be 3.14, yes? So we know that 2.3 is indeed less than 3.14. We just need to figure out, is our 2.3 bigger or smaller than pi over 2? We can take the calculator and tell it to divide pi by 2, 1.57. So here our 2.3. Our 2.3 radians is going to be somewhere in pi over 2 to pi. Which means to find this reference angle here, we're having to take pi and remove 2.3 away from it to find this other angle. And again, we can let the calculator do this here. Pi minus 2.3 will go out 4 decimal places, 0.416, 0.8416. Would be the reference angle. So sometimes, especially for these here, finding the reference angle in radians, it might be easier to convert it to degrees, figure out what the reference angle is in degrees, and then just convert it back to radians with our pi over 180 or 180 over pi. Questions on any of these here so far? Questions on anything we've done so far? All right. We're ready for the last one, negative 135 degrees. Now, 135 degrees, we would go from here to here, and we would end up in quadrant 2, because straight up is 90, negative x-axis 180, 270, and all the way around is 0 and 360. But we're not going 135 degrees. We're going negative 135. So for us to go negative 135 degrees, instead of going clockwise or counterclockwise, we're going to go clockwise 135 degrees. Well, that means straight down is negative 90. Straight across is negative 180. Up is negative 270. And back where we started would be negative 360. And the angle for our reference angle will always be positive. It will always be a positive angle. So we're taking this 135 degrees away from what? 180. And if we take it away from this here, we get 45 degrees. Now, there's other ways to get to this, because if we wanted to, instead of doing it this way, what I could have found is the coterminal angle for a negative 135, the positive angle. To do that, we would add 360 to it. And I'll do this over here. Because if I add 360 to our negative 135, 5, the coterminal angle would be 225 degrees. So going the other direction, this way, we would get 225 degrees. We'll have 225 minus 180. 5. Still gives us a reference angle of 45. So they are the same. Questions on this here? We'll stop there. Planned on getting further, but we'll stop here. We'll finish this up tomorrow.